solve by taking a square root, we would have to simplify radicals. So at this point, I won't accept rounded answers anymore. All right, for square roots, we're actually going to be simplifying them. Now, to make it a little easier on you, all right, you guys need to know your perfect squares. So what I did is I went ahead and printed off a sheet that had all the perfect squares and their square roots on it, 1 through 20. All right, those are the main ones you need to know. Now, my recommendation while we're doing this lesson, have this next to you because it'll make your life easier so you're not having to put things in your calculator a bunch. All right? But at the very least, I expect you guys to know your perfect squares up through 12. All right? And in a perfect world, 15. But I gave it to you 1 through 20 because those are the ones you will see the most. All right? So as we do this lesson today, just have that out on your desk because, again, it'll be a good reference for the stuff we're doing today. Okay, so go to your packet, very first page. So, square roots. All right, when I say square roots, what do you guys think of? What does a square root do? Owen.
So a square root in my mind is like a number times itself.
So that's a perfect square. All right, a square root's a little bit different. What does a square root do? It does relate to perfect squares, though. So if I asked you what the square root of 9 is, what would you tell me? What's 3 squared? 9. So doesn't a square root undo a perfect square? So it's not division. A square root undoes a perfect square. That's what it does. All right, so if you square something, a square root will undo that. So square roots, cube roots, and higher level roots are important because they're the inverse operations of squaring and cubing. All right. Specifically, we deal mostly with square roots. All right. Now, let's look at some very basics. So these are all perfect squares. All right. So, Abby, what's the square root of 25? Good. Kyrie, what's the square root of 9? Good. Zachary, what's the square root of 100? Look at your reference sheet. Good. Bella, what's the square root of 0? Good. Now, those were basic ones. These last two, they are fractions, but they're actually pretty easy. Because, do you guys see how there's a perfect square on the top and the bottom of 1/4? So we could rewrite this as the square root of 1 over the square root of 4. So what's the square root of 1? 1. What's the square root of 4? 2. So the square root of 1/4 is 1/2. So if we use that logic, what would be the square root of 64 over 9? 8 over 3. So this would be the square root of 64 over the square root of 9. So this would be 8 over 3. So taking square roots of fractions, as long as there's a perfect square in both the numerator and the denominator, it's just you take the square root of the top, take the square root of the bottom. Now, why is this important? Knowing your perfect squares will help you simplify. All right. Now, there's something else we have to consider when we're doing perfect squares. All right. So far, what we've been learning, or at least what you have known so far, is that every square root is positive. All right. So if you take a square root of a number, you get a positive number. Is that always true? Let me ask you this. are there numbers that when you square them, that will get the exact same number? So for example, can someone name me two numbers that would give me 9 if I squared them? So if I squared two different numbers, they would equal 9. Which two numbers?
81.
That's the square of 9. So in other words, guys, if I have some number squared, that's going to equal 9. And I have another number squared, that's going to equal 9. What are those two numbers? What's one number that if you square it, it equals 9? 3. What's the other number? -3. Good. So remember, both the positive and negative version of a number gives you the positive square root. There's no such thing as a positive square, There's no such thing as getting a negative square. So that is what it's stating here. So positive real numbers is kind of the consensus of what we've done. But technically, there's always going to be a positive square root and a negative one. All right. So in reality, what we're going to end up having to do is that we have to state both of them. So if I ask you to take the square root of 4, what would be two numbers that would equal the square root of 4? 2 and -2. Now, a way we can shorthand this is with this sign, plus minus 2. So all this means is that it's both the positive and negative version. So the positive and negative of 2, that's what we can say. So but we call that sign plus minus. What about 36? If I took the square root of 36, what two numbers would that be? Plus or minus 6. Good. So in reality, guys, it's not really hard to think about. All you got to do is just whatever the square root is, just throw a plus minus in front of it. What about if I took the square root of 1 over 16? Right, plus or minus 1/4. Square root at the top, square root at the bottom. All right. So that's going to be important with quadratics because remember, solutions in quadratics are what key feature? What key feature is also known as the solutions of a quadratic? X what?
Intercepts.
Intercepts, good. So x intercepts. Now, typically, how many x intercepts are there typically in a quadratic? 2. All right. So that's where this plus minus is going to come into play a lot because more often than not, when we solve a quadratic, we're going to have to undo a square at some point. Square roots undo a square. So when we get that answer, we put a plus minus in front of it because those will be the two different answers. All right. And again, we're not there yet. We'll get to it. So this next one, they gave us this function, f of x is equal to 20 plus the square root of x plus 3. And they're asking us to find what the value of f of 46 is. So what do you think is going to be my strategy here? So look at the f of 46. What is this 46 replacing? In the x. So what do you think I'm going to do there? Plug 46 in for x. So I'm going to do 20 plus the square root of 46 plus 3. Now, in this case, if we were doing order of operations, the square root is currently, what's under the square root is currently acting as parentheses. All right, so we can imagine that there's parentheses under here. So what's 46 plus 3? 49. So I have 20 plus the square root of 49. Now, technically, this square root is considered an exponent, which we'll learn about a lot later, but it is technically considered an exponent because it undoes a square, which is an exponent. So we have to do that square root next. What's the square root of 49? 7. So this would be 20 plus 7. So what's my answer? 27. Now, another things about square roots is that they have a very interesting property when it comes to multiplication. All right. So, here's what I want you to do in your calculator. I want you guys to type in the square root of 4 times the square root of 9. So make sure that you separate the square roots. So I'm going to hit second square root 4. Use my arrow key to get out from under the square root. Times second square root 9. So that's what it should look like in your calculator. And then what do you get? 6. Why does that make sense? What's the square root of 4? Square root of 9? 2 times 3? 6. So square root of 4 is 2. Square root of 9 is 3. So that equals 6. Now, look at letter B. All right. They did the square root of 4 times 9, but it's all under the same radical. So try putting that in your calculator. So in your calculator, you're going to put square root 4 times 9. And it's all under the same radical. So now it looks like this. What do you get? 6. Why does that make sense? So now we have to do the 4 times 9 first. What's 4 times 9?
36.
36. Well, what's the square root of 36? It's 6. So, what do you think is true about multiplying radicals? So look between A and B. Using the same numbers, the only difference is the first one they had the radicals separate. The second one they had both numbers under the same radical. What do you think is true? Take a shot in the dark, guys. What do you think is true? It's about what you think. All right? I don't care if it's right. Just ask me what you think you know. It's still the same. All right? So regardless of how we write it, whether it's two numbers under different radicals or the same two numbers under one radical being multiplied together, we get the same answer. All right? Let's see if it still works with the next examples. So let's just do this one by hand. So what's the square root of 4? Square root of 25? 5. What's 2 times 5? 10. So we're going to think that this next one should equal 10 if that property holds up. So this time we got to do 4 times 25 under the radical. What's 4 times 25? 100. So we got the square root of 100, which is what? 10. So does that hold up in court? Yep. So that is the property here. So the multiplication property of square roots is simply if you have the square root of A times the square root of B, so two separate radicals, it is the exact same as the square root of A times B. And the opposite is true. If you have the square root of A times B, That's the exact same thing as the square root of A times the square root of B. So in other words, you can either combine them or multiply them. All right. So in other words, we can use this property when we have unfriendly square roots. What do you think I mean by unfriendly square roots? They don't give us something even. It'll give us a really weird decimal if we put it in our calculator. All right. Well, look at letter A. So I have the square root of 2 times the square root of 8. Are either one of those two numbers perfect squares? No. All right. So how could I rewrite this so I can make it so there's a perfect square under the radical? Use the property we just learned about. Right. Change it so we have one square root, but we're multiplying 2 and 8 under it. Because what's 2 times 8? 16. Is 16 a perfect square?
Yes.
Yes. So now we got a nice square root, which is what? 4. Yes. Yes. All right. What about B? So if I rewrite it, what would it look like? Square root of what? 12 times 3. So that's the square root of what? 36, which is good. So this last one, how would I rewrite it? 20 times 5, which is what? 100. Square root of 100? 10. So why are we learning this property? At some point, this will help us when we're simplifying radicals. All right, but in reality, we'll be going in the reverse. So we'll be taking a radical with multiplication under it and separating it into two radicals. So now we're looking at the simplification of square roots of non-perfect squares. All right. So this is a fairly antiquated skill that is almost completely irrelevant to algebra, but it often arises with standardized tests. So a lot of you guys are sophomores. You're going to have to take the ACT next semester, or next year, sorry. I guarantee that this will be on it at some point. All right. So knowing how to do this will help you out a lot. It'll also help out in Math 3 because you will see it again, but in a harder context. All right. So just learning how to do this, and it's honestly not very hard, but learning how to do this will be very helpful. All right. So first off, we're going to list out all the perfect squares, starting with 1, and we're going to go through 10. All right, so first 10 perfect squares. So what's my very first perfect square? So 1 squared. 1. Next.
2 squared. 4.
Right. Next. 9. That's 3 squared. Next. 16. Next. 25. Next. 36. Next. 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 And finally, so that is the very first 10 perfect square numbers. So if you squared 1 through 10 in that order, those would be the numbers that you get. Now, again, you got that reference sheet, so you don't really need to. I recommend using that reference sheet as much as possible because the more you use it, the more you'll actually remember these perfect squares. All right, so they'll almost become second nature to you. I've done perfect squares enough. I can go up to at least 16, even 20 without even thinking about it. All right, or without even having to put in a calculator. But that's because I've done it so much. So the more you do it, the better you get at it. Now, let's look at letter B. So we're going to consider the square root of 18. Okay? So we know, is 18 going to be a perfect square? Is 18 a perfect square? No. So if we put this in our calculator, we're going to get an irrational number, meaning we're going to get a really funky decimal. Okay? But could we divide 18 by something? Or is there a factor of 18 that is a perfect square?
Yes.
What is it? 9. So 9 is the perfect square in 18. And 9 times what is 18?
9 times 2 is 18.
Right. So, and 9 being the perfect square. So, here's how you simplify the radical. All right. You want to rewrite 18 as multiplication of a perfect square and another number. All right. So, what I usually tell kids to do is divide whatever number's under the radical by your perfect squares. All right. Because it doesn't matter if we don't have perfect squares. So divide by your perfect squares until you get the biggest one possible. All right. Meaning you want the biggest perfect square to divide into that number possible. So let me ask you this. Which of these perfect squares would make sense to divide into 18? In other words, like which number can I not go past if I was testing this?
16.
Right. We wouldn't be able to go past 16 for this one because obviously once we start dividing by bigger numbers into 18, we'll start getting fractions, which is not what we want. All right. So in reality, if I was testing this, I would divide 18 by 1, 4, 9, and 16. Now I know y'all know that the only factor there is 9. I'm talking about when we get to some big numbers. All right. This is how you would do it. So then once you figure that out, we're going to take this 9 times 2 and we're going to replace it into the square root of 18. So we're going to rewrite this as the square root of 9 times 2. Now, what is true about what you see right here? Couldn't we rewrite that square root of 9 times 2? How can we rewrite that? So you look at the property that we just learned previously. How could we rewrite that? Good. We could separate the radical to be the square root of 9 times the square root of 2. Well, now we got something that we can simplify. What's the square root of 9? 3. So this is equal to 3 times the square root of 2. And we know the square root of 2 doesn't simplify, so we leave it alone. So the simplified form of the square root of 18 is 3 square root 2. And that represents 3 times the square root of 2. And that's how we simplify. So simplifying radicals is relatively easy. Okay? All you have to do to simplify radicals is, the key to simplifying any square root is to find the largest perfect square that is a factor of the radicand. A little vocabulary there. Radicand is the number under the square root. So the number under the square root is known as the radicand. So you may hear me say that a lot. All right. Then you rewrite it as 2 different square roots and simplify the perfect square. All right. So let's try some more. And by the way, if you don't believe me that those are congruent, let's actually check in our calculator real quick. So if I type in the square root of 18, that's not 18, I get this funky decimal. Well, now let's type in 3 square root 2. See if I get that exact same decimal. Do I? Yes. So they are congruent or equal or whatever. All right, so let's try some more of these. So 8. All right, look at your list of perfect squares. All right, what is the biggest perfect square that you think will divide into 8 evenly? 4. All right, so 4 would be the perfect square. And 4 times what would give me 8? 2. So I'm going to rewrite this as 4 times 2 under the radical, where 4 is my perfect square. Now, what do I do then? Separate it. So I have the square root of 4 times the square root of 2. And then I just simplify my perfect square. What's the square root of 4? 2. So this is 2 square root 2. And again, guys, if you have doubt that you didn't get it right, just take a minute, plug in the square root of 8, and then plug in the square root of 2 square root of 2 in your calculator, see if you get the same decimal. Easy check. All right, let's try another one. 45. So look at all your perfect squares. So all your perfect square numbers. What perfect square could divide evenly into 45, and it's the largest number that can divide into 45?
36.
So 36 doesn't go evenly into 45. Not 16 either. So guys, in other words, what's the largest perfect square that divides evenly into 45?
9.
9. It's 9. So we'll have the square root of 9 times what? 5. So how do I rewrite that? Good. Oops. So that'd be equal to what? So what's the square root of 9? 3. So I have 3 square root 5. You guys understanding how this works? Pretty easy, right? All right, what about 48? What is the biggest number that you can think of that will go into 48 evenly? So in other words, take a minute in your calculator, test your perfect squares, dividing them by 48. And which perfect square should you possibly stop at? So you shouldn't go past 36 when you're checking. All right? So don't go past 36. So take a minute. Don't say it yet. But figure out which would be your biggest perfect square that goes into 48. So if you get 1, because there's more than 1 in this case, that works. If you get 1, keep going and see if there's a higher one. So, first off, what 2 numbers in your perfect square list will go evenly into 48? So what 2 numbers in your perfect square list will go evenly into 48? 4 and 16. And which one's the biggest? 16. So we're using that one. Now, could we use 4? Yes. The problem with using 4 is that we would end up getting a radical that needs to be simplified again. All right. So you could use 4, but you end up having to simplify another radical again. So that's why I say use the largest one, because it's a one and done. All right. So what times 16 gives me 48? 3. So I'll rewrite this as the square root of 16 times the square root of 3. So what would my answer be? Someone who has not talked yet today. 4 what? Square root of 3. Good. All right, try letter E on your own. So letter E, try that one on your own. So use your perfect square list and divide your perfect squares into 72 until you get the largest one possible that you can use. So in reality, you should not go past 64 when you're checking. This one's going to have a couple that works, but remember, you want the largest one. So don't just settle for the first one you get. Keep checking and make sure there isn't a bigger one. And remember, you're just dividing 72 by those numbers. So 72 divided by 4, 72 divided by 9, so on and so forth. Once you do that, let's break down the radical. Thumbs up if you're ready. One more minute. All right. Let's go with Cohen. What were the possible options for perfect squares that could go into 72? 36. What was another one? Not 2, but so 36, and what was the other perfect square that can go into 72? So 4 works and 9. So there were 3 that could possibly work. And Cohen, which one would you pick? All right, so 36 is clearly the one that works. So, Caden with the C, how would I rewrite the radical using 36? So 36 times what is 72?
Times 2.
Times 2. So I'll rewrite this as 36 times 2. What would I do next, Carolina? Good. What would I do next, Arielle? Square root of 36, which is 6. So what's my answer? Good. All right. Last one I want to talk about. So be careful. This one has a negative symbol in front of it. Now, as long as a negative is outside the radical, we can still apply it. So basically, we're going to simplify the square root of 500 and then whatever it is, multiply by a negative. Okay? So just by looking at this, what do you think the highest perfect square is going to be? 100. All right? Because remember, if it's 500, it's clearly going to be divisible by 100. Which, by the way, another one that would have worked is 25. But again, 100 is the biggest, so that's the one we're going to use. So how can I rewrite the square root of 500 with using 100? 100 times 5. So if I separate, this would be negative 100 times the square root of 5. What's the square root of 100? 10. Now, since this negative is on the outside, we're going to say this is negative 10. And still leave it as square root of 5. So don't apply the negative under the radical. But if there's a negative on the outside, just keep it on the outside. All right? So that's what this one would look like. Any questions on simplifying radicals? All right. One last thing I want to talk about. And that is irrational numbers. All right. So irrational numbers is very, very quick. So far in mathematics, the typical numbers that you have been using is what we call rational numbers. So they can be basically written as a ratio of two integers, meaning they can be written as a fraction. All right? So they can either be written as a fraction or a whole number. So negative 1/2, that's a rational number. 3/2, rational number. 4, rational number. Negative 1,000,000, rational number. All right? Basically, they are terminating decimals, if you were to put it in the calculator, or repeating decimals. So for example, 1/3 is a rational number because if you put in your calculator, it will give you 0.33333333, goes on for a million years, but just a bunch of threes, keeps on going. All right. Now, an irrational number, it's clearly, well, not rational. That's what irrational means. It means not rational. What represents it is that it cannot be written as a ratio of two integers. So no matter how you slice it, it's not going to turn into a fraction. We could put in our calculator all we want, hit the fraction bar. It would never generate a fraction. So typically, what makes it irrational, it has a non-terminating and non-repeating decimal representations. Now, here's my question. So in other words, under the real number spectrum umbrella, there's rational numbers. That's where integers, whole numbers, and natural numbers fall under. So if you guys look over here. So look over here. So this poster right here. This is the real number picture. So rational numbers is this big circle right here. And notice how integers, whole numbers, and natural numbers fall under it. That's the numbers that we're used to. Irrationals is its own little subsection of real numbers. Now, does anyone know what the most famous irrational number is? It's pi. So, an example of an irrational number is pi. So that would be 3.1415, so on, so and so forth. There's no rhyme or reason to how they repeat. They just keep going on forever and ever. That's probably an irrational number that you've dealt with the most. Now, more often than not, why is this important? Because more often than not, non-perfect square roots typically give you irrational numbers. That's why they give you those funky decimals. So let's consider the number that is rational and one that is irrational. So we're going to look at 2/3 and the square root of 1/2. So both of these numbers are less than 1. All right, so let's go back to kindergarten for a second. If I drew a picture version of 2/3, what would it look like? How would I separate this rectangle? Into thirds. How many would I shade? 2. All right, so we're going back to kindergarten a little bit there. Or I guess that's more first grade. Now, if you put 2/3 in your calculator, what would the decimal be? So it'll be 0.6 repeating. More often than not, they round it off at 0.67, but oh Lord, I knew one of y'all was going to do that. But technically it's just 6 repeating, but they just your calculator will round it off at some point. Now, take a minute, put in the square root of 1/2 in your calculator, so square root of 0.5, and tell me all the decimal places you can see on your calculator.
707.
So 0. What?
707.106.781.
All right. Those are all the numbers that your calculator gives it to us. So if we want to draw a picture version of the square root of 1/2, why could we not do that? Right. It's not a pretty fraction. Like if we could do about 66% of this bar here. All right, because it's 2/3. If we used a ruler and did exactly, it's a very easy measurement. But right here, we couldn't because first off, that will never convert to a fraction. Second off, that's not even the full calculation for it. It will keep going forever and ever and ever with numbers with no rhyme or reason pattern. All right, so the reason we couldn't is because the square root of 1/2 is irrational. Now, we're going to skip exercise 2 because all it is that you're just going to put those in your calculator, write out all the decimal places that you see. Just know that all 3 of these are considered irrational numbers because the decimals will never end. There's no rhyme or reason. There's no clear pattern of how they're repeating. They're just random numbers, keep on going on forever and ever. Now, think about this one carefully. Irrational number is a square root of 28. So without using your calculator, what 2 consecutive integers do you think the square root of 28 will lie under? So think about this for a second. What perfect squares is 28 in between? So what 2 perfect square numbers is 28 in between? 25 and 36. So 28 is between 25 and 36. So if we took the square root of all those numbers, the square root of 28 would be between which 2 numbers? 5 and 6. So the square root of 28 would be between 5 and 6. Put that in your calculator now, see what you get. So put the square root of 28 in your calculator. So what do you get? Keep going. I want all the decimal places. Okay, repeat. I had like 2 people talking at the same time. So 2 what?
5, 0, 2, 6, 2, 2.
Is that number between 5 and 6? Yeah. All right. So that's kind of a way, like if I ever ask you what two consecutive integers is this irrational number between, just think about what two perfect squares the number under the radical is between, and then take those square roots. All right. Now let's put this in simplest radical form. So what is the greatest perfect square that will divide evenly into 28? So look at your perfect square chart. What would be the greatest perfect square that would be a factor of 28? 4. So I'm going to rewrite this as 4 times what? 7. Rewrite this as the square root of 4 times the square root of 7. So what's my answer? Good. Now D is just saying if we put 2 square root of 7 in our calculator, it's asking what we get. It should be that exact same answer that we got in letter B. Almost done. So it appears that a non-zero rational number times an irrational number results in an irrational number. So in other words, 2 is a rational number. So that's rational. Square root of 7 is irrational. So if we multiply a rational and an irrational number together, we get an irrational number. All right, that's always true. Rational times irrational is irrational. All right. Now, let's investigate some things that happens when we add or subtract rational numbers to irrational numbers. So here's what I want you to do. Put this first one in your calculator. So do 0.5 plus the square root of 2. And tell me what you get. Like, do you think it's going to be a rational or irrational number? So if I put this in my calculator, I have 1 divided by 2, and I'm going to put that in parentheses to represent 1/2, plus the square root of 2. All right. Now, if you don't know for sure if that's rational or irrational, here's a good way to check. If you hit the math key, which is underneath that green alpha key, do you guys see how number 1 says frac? That's short for fraction. You hit enter. What this will do is convert that decimal to a fraction if it's able to. So if I hit enter, does it give me a fraction? No. It just repeats it. That means that it's an irrational number because your calculator can't even calculate what would it be as a fraction. So what this would give me is an irrational number. So let's just take a guess here. What do you think is going to happen with B and C? They're also going to be irrational. So essentially, when a rational number is added to an irrational number, the result is always irrational. So if you do a rational times an irrational or a rational plus or minus an irrational, you still get an irrational number. All right. Last one. So let's look at this question. They want to know which of the following would give me an irrational number. So let's go ahead and eliminate ones that we know for a fact is not irrational. Someone name me one answer choice that's not irrational, so it's rational. 1. Why? Right. Square root of 25 is 5. Even though it's a square root, don't be fooled because there's a perfect square under it. What's another one I can eliminate? Why can I eliminate 2? Right, because what's the square root of 9? 3. So technically this is 4 minus 3, which is 1. And then someone else, what's the last one that we can eliminate? So irrational numbers cannot be what? Fractions. So what can I eliminate? 3. So remember, irrational means not rational. And remember, the key word in rational is ratio, meaning fraction. So it cannot be a fraction. So 4 would give me an irrational number. All right. So that's it for notes today. Now, before I tell you what your assignment is, it is going to be a Delta Math, but before I tell you what your assignment is, we're actually going to play a little game. All right. So you're going to still want that reference sheet out, maybe your notes as well.